Today's topic covers the associative and commutative properties in detail. It is partly a review, but there is a new application involved. And this goes along with topic 4 of section 1. So in order to understand this, we need to understand what is an equivalent expression. It's when two expressions have equal value, even though they might look different. So the word equivalent has the word equal in it. So you have 2x plus 10 and 3x plus 5 when x equals 5. I could plug 5 into both of those and they would be equal. See, 2 times 5 plus 10 is 20, and 3 times 5 plus 5 is 20. So while those expressions are completely different, they have the same value. Our commutative property tells us that when we commute, we move around, okay? When you're commuting, you move. So it allows us to move terms, but keep the expression's value the same. So its value is never going to change. This only works with addition and multiplication, because when you move subtraction and division around, you're going to change values. But the key word is that the order changes. So what does that look like? Well, for addition, if you look at the left side of this equal sign, I have 5 plus 10 plus 3. Well, when I move to the other side, I have 3 plus 5 plus 10. Again, both sides' value is the same. They're just written in a different order. We can also do this with variables. Notice that I have x plus 2 plus b. Well, on the other side, I have b plus 2 plus x. The x and the b switch spots. Even though parentheses look like they moved, they didn't. The groups stay the same. It's still x plus 2 inside. And that's important to keep in mind. For multiplication, again, it's the same thing. Your value is going to stay the same. You're just going to move numbers around and you're still multiplying. We can also do this with parentheses as well. As long as one number moves positions, it's the commutative property. It has moved. It's commuted places. Our next property is the associative property. This property comes from join or connect when you associate, okay? So it allows us to regroup terms, but with parentheses, but again, the value stays the same. It also works only with addition and multiplication. Now, with this, order is going to stay the same. If order changes, it was the commutative property. What changes here with associative is the groups when the parentheses move. So here's what that looks like. So with addition, notice how it's 5 plus 10 plus 3. Well, the other side is 5 plus 10 plus 3. What changed is my group. On the left side, the 10 was with the 5 in parentheses. Well, now on the right side, the 10 is with the 3. Same thing with variables. As long as your order is staying the same and the parentheses are moving, that's what makes it associative. It's associating with a new member of the group. It doesn't change with multiplication, okay, whether it's variables or numbers. Now, another property that's not as heavy but it's important to understand is the identity. Your identity is a unique characteristic. It defines who you are. There's no one out there like you, okay? It allows you to add or multiply a number, and that number will stay the same. The number's not going to change its value on the other side. Okay? Again, only works with addition and multiplication. So if we look here, think, what is the only number I can add to something to keep it the same? 0, right? Even adding 0 to a variable, the variable still stays the same. Now, when I come to multiplication, it's important to remember, if I multiply something by 0, it's going to be 0. So my identity property when it comes to multiplication is when I multiply something by 1. Anything times 1 is still that number. It's still keeping its identity. Remember, what we're wanting is both sides to stay equal. Same thing with a variable. If I multiply y by 1, I still get y. So it's important that you have what I have written here in green. So take a minute to pause if you need to write these down. So let's take a look and see if we can identify which property is done here. So here's how I do this. I start with the left side of my equal sign. I'm starting with my first problem on the left, the 5 times 3 times 2. I look at the left side and I go 5, 3, 2. I then shift over to the right side and I see that it says 2, 3, 5. So that tells my brain that it is the commutative property. Why is it the commutative property? Well, because the order changed. The 3 and the 5 are still in parentheses, so even though it looks like the parentheses moved, it didn't. It still has the same group in there. So let's go over to my other one. I have y plus 2.5 plus 28. Then I go to the right side. I have y plus 2.5 plus 28. So that's the associative property because the groups changed. Notice how I don't even really look at the parentheses. I kind of ignore them. And I'm just looking at either the variable or the number. And I'm going through and seeing if the order is the same. Does that help? Okay. So then you try. Pause the video now and try these on your own. Don't let variables or radicals or anything like that throw you. We're focusing on, does the order change? If the order doesn't change, then look to see if the group changes. Okay, let's see how you did. So on my first one, I have x, y, then z. And then I have x, y, then z. So what I notice is order is the same, so it can't be commutative. But then I look at my parentheses and I notice that my y now has a new grouping. So that is the associative property of addition. The groups changed. Then I come over to my other problem. I have x times the square root of y times z. Then I have x times z times square root of y. Right there, the order is not the same, so it is the commutative property of multiplication. My order changed. Okay, so let's take a look at an algebraic proof. This is the exact reason why you would need to be able to identify the properties, because you have to justify how you reached your answer. This proof breaks it down for you. You're eventually going to have to break it down. We all know why 5p times 4q equals 20pq. You've all been doing it for a couple of years. But now you have to justify each step along the way of how you got there. So if you take a look at the problem, the first step says that they broke apart and they are now grouping p with the 4. They put those in parentheses together. They're saying to do that. What allows you to do that there was the associative property. You regroup them. Originally, the 5 is with the p, but now the p is with the 4. Okay? Then what they did within the parentheses is they flipped the order of the 4 and the p. What changes the order? You got it, the commutative property. So now you've got your numbers next to your numbers and your variables next to your variables. They then regroup them. Well, what allows you to regroup? The associative property. And then at the end, you simply simplify, okay? So that's how you got the 20pq. You multiplied and you simplified down the expression. So do you see kind of how a proof works? Okay, so take your time, pause if you need to, but what I already did here for you was I broke it down. So if you look at the left-hand side, that's the problem. 4 plus 7 times m squared plus n squared. So what did we do here? Was it the associative property, the commutative property, or the distributive property? What started this problem off? Pause now and see if you can fill in those blanks along the way. Okay, let's see how you did. So if you notice, it was 4 plus 7 times the quantity of m squared plus n squared. When we come over to the other side, I now have 4 times the quantity and 7 times the quantity. That is the beginning of the distributive property. You distributed the 4 to both and the 7 to both. And you actually go through and do that multiplying on that next line. That's also the distributive property. Sometimes we break that same property down into 2 steps. Okay? I never said something can't repeat. So that's how you had that same property repeat. Then if you take a look very closely, that 4n squared and the 7m squared right in the middle, the two right in the middle, they switch spots. So my order changed. So when your order changes, that is the commutative property. Then at the last line, I just combined like terms and I simplified. So right now, we're about 4 lessons in. You should have subscribed below, but more so, take time to reflect, summarize. What did you learn? What is difficult for you? Write down what you might need to practice more on, maybe proofs, breaking down those proofs. Comment below with questions or something that you might have learned.